Hello and welcome to Raza Academy. Today we are going to study about the very important topic of quantum physics, which is Heisenberg's uncertainty principle. According to this principle, before I tell you about the Heisenberg's uncertainty principle, we need to understand that particle can also show wave property. How this is well defined, well explained by a scientist, G. Broy, in his hypothesis. That means if we have particle that shows wave property, and that particle is very small, very small, that is microscopic in nature, microscopic in nature, then simultaneously and accurately finding its position and momentum then finding it simultaneously and accurately its position and momentum is next to impossible. That means अगर हमारे पास कोई बहुत छोटा सा माइक्रोस्कोपिक पार्टिकल है तो उसकी पोजीशन और मोमेंटम को साइमल्टेनियसली मतलब एक साथ और एक्यूरेटली मतलब एग्जैक्ट उसकी वैल्यू निकाल पाना इम्पॉसिबल है. यानी दिस इज समथिंग which cannot be determined. So according to him, the exact and simultaneous determination of position and momentum of a moving microscopic particle is impossible. That means even if you try your best, even if you know a lot of physics and everything, it is next to impossible to get the exact and simultaneous value of its position and momentum. Suppose that the particle is right here. If you get its position, then it is completely impossible for you to find its momentum. And if you get the momentum of this particle, so it is completely impossible to determine where the particle is. It is completely impossible to find where the particle is, where the particle was. Now, that means if a particle m is moving with velocity v, which is known by you exactly, you are very much sure what its velocity is and you are very much sure about its mass as well. That means you will get the exact value of momentum. If you get the exact value of momentum, you will come to know that you don't know the location of it. You don't know about the whereabouts of the particle. You don't know about the position of the particle. So if we do not get its value accurately and we assume that its momentum measure error is equals to delta p. P, that means momentum is something which is proved by second law of Newton, and it is actually denoted by the symbol p. And if we talk about its position, so its position measure error, because you can't find the exact, so we are just taking the error. Maybe if the value is from 2 to 3, we don't know, it could be 1.5, it could be 2.5, it could be 2.75. so we assume that if it is in between this bracket, then the error will be 3 minus 2. So we are talking about the error of momentum and the position error. For example, it is delta x. So according to the Heisenberg, the minimum value of the product, that means the minimum threshold, minimum value of product means multiplication of momentum and position will always be equal to or greater than or greater than h over 4 pi. That means if we write it mathematically, so we will end up writing like this: delta p dot delta x, that means the multiplication of the product of delta p and position, that means delta x, is of course is going to be minimum at least h over 4 pi. It could be more than that. So technically we can write it like this: more than or equal to h upon 4 pi. Again, I will recapitulate everything. Heisenberg uncertainty principle states that it is next to impossible to know both the exact position and the momentum of the particle. If you get the position, you will end up thinking about its position, which cannot be determined. If you get the position, you will not get the momentum. So this is what is Heisenberg's uncertainty principle is. So it is completely based on duality of particle, that means particle nature and wave nature, and it has always been the cornerstone of quantum physics. Thank you so much.